Let's see, Jackson, help me remember. What is a system of equations?
It's a pair of equations.
Okay, a pair of equations. And a solution to a system would be?
A pair of numbers that would make both equations true.
Excellent. I like the way you said that. A pair of numbers that makes both equations true. Okay. Well, in this lesson, we're going to look at a system of inequalities. So all we have to do is take what you said and just turn the word equation into inequality. A system of inequalities is two or more inequalities, and a solution would be a pair of numbers that makes them all true, no matter how many there are. Okay? So let's look at an example of a system of inequalities. Suppose we have x plus y is less than or equal to 10. I think I'll use different colors here. X is greater than or equal to 4, and y is less than or equal to 3. So here we have a system of 3 inequalities. And what we want to do is figure out which points make all of them true. All 3 inequalities true. So what we're going to do is we're going to graph all 3 of them and then figure out which points make them all true. So let's just concentrate on the first one. Its boundary would be a line, okay? And that line would be this equation. Okay, tell me how to graph that, Becca.
You could use the point slope formula.
Okay, tell me how.
By making the x 0.
Oh, okay. So what she's saying is, let's let x be 0. And if x is 0, then I could just ignore it. And y would end up being?
10.
10, yeah. So that's the y-intercept, right? Up here somewhere at 0, 10 is our y-intercept. And then?
And then if the y was 0, the x would be 10.
If y were 0, then x would be 10. So over here somewhere is the x-intercept. And so the line has to go through those 2 points. Now that's actually called the intercept method. Okay? Point slope was that thing. Remember that? Okay. So you did the right thing, you just didn't call it the right thing. I like what you did, though. You figured out that the boundary of this inequality is this line. Okay? Now what do I do next? Since it's an inequality.
Test a point.
Test a point. Let's test the origin. If x is 0 and y is 0, do I get a true statement?
Yeah.
Yes. So the origin's on the correct side. So our first inequality would consist of all of these points on the origin side of that line. Okay? So we're 1 down and 2 to go. We've taken care of this one. Now you guys are lucky. You've got the easy ones. Okay? Isaac, tell me about x is greater than 4. Greater than or equal to 4.
So we would have a vertical line at positive 4.
Okay, so that would be about here, a vertical line. That's the line x equals 4.
And it would be, because everything's greater than 4, it'd be everything to the right of that.
Everything to the right of that line. Like so. Okay? Now already I want you to start thinking about which points make these 2 inequalities true and which points make them false and which ones make one of them true and the other one false. It's very easy to tell. Notice that these points up here in this little wedge, they didn't get shaded at all. That means they don't make this one true and they don't make this one true. These points over here got shaded blue, but they didn't get shaded green. So they make this one true, but not this one. Okay? But notice all these points down here, they got shaded twice. So that means that they make this one true and this one true. So what we're talking about here is the overlap again. It's the intersection of these sets. And we want all three of them to be true. So we got one to go, Jackson, and this one's yours.
Horizontal line,
Horizontal line at
3.
3, so that would be about here.
And shaded down.
And shaded below that line. Now, this gets a little bit crowded sometimes to tell what points got shaded 3 times. We have to figure out what points got shaded blue and green and white. These points up here didn't get shaded white. These points over here didn't get shaded green. These points up here didn't get shaded blue. But I think you can see that this set of points right here, they're below the blue line, to the right of the green line, and below the white line. Those are the points that got shaded all 3 times. So that region, it's got a boundary here, and a boundary here, and a boundary here. That region is the solution to that system of inequalities. Now, like I say, this gets a little bit crowded, so I would like to do another example and give you a way that you can not have such a messy picture. Okay? So here's a second example. And by the way, while I'm erasing here, let me say that this idea of solving a system of inequalities, it just seems like, oh, well, you're getting some pretty pictures. But there's a big branch of mathematics called linear programming. And people in business use linear programming all the time to solve big business sorts of questions. How to maximize their profit, how to minimize their costs, and so forth. And this idea of drawing these graphs is the first step in doing linear programming. So it's not that we're just drawing these pictures for fun, okay? Let's just do two inequalities this time. Let's say that the first one says y is less than or equal to 1/2 x plus 2. And the second one says y is greater than or equal to negative 2x minus 3. So that's a system of 2 inequalities in 2 variables. And so just like in the last example, except I'm not going to use color this time, we want to first of all draw these 2 lines and then shade. And this time I put my equations in slope-intercept form. So this first one has a y-intercept of 2 and a slope of 1/2, which means that every time you run 2, you only rise 1. Okay? Now we're including the line, so I'm going to put that line in nice and solidly. And then we've got to decide which way to shade. Okay? Now, frankly, when the equations are in this slope-intercept form, you can use that idea of less than means below and greater than means above. Okay? See, there's no minus sign in front of this y. So this works. If this says less than, I know I'm going to be below that line. You see, if I check the origin, I would have 0 is less than 0 plus 2, which is true. But instead of shading, that's where these pictures get kind of crowded. I'm just going to put some little arrows like this to help me remember that my first inequality is every point below that line. Okay? And we're already half done. Now let's do the same thing with this one. This one has a y-intercept of -3, and it's got a slope of -2. So if you go over 1, you go down 2. So that line looks about like that. Okay? And this says greater than this time, so we want to be above that line. So I would shade above that line. But instead of shading, I'm just going to put these arrows to help me remember that the solutions to this inequality are everything above that line. Now you can just look at that picture, and I think it's much cleaner than it was before. You can see that we want to be below this line and above this line. So now you can shade your answer, which is the overlap. Everything that's below the first line and above the second line. So that would be the solution to that system. Okay? So that's just my suggestion when you're doing these by hand. Just use these little arrows instead of all that shading, because especially if you have 4 or 5 inequalities, it just gets too crowded and you can't tell where the overlap is.